Okay, hi students, this is Mrs. Kang and I'm going to go over our next lesson, which is Module 2-1, Greatest Common Factor. So our goal, if you read here, it says you will determine the greatest common factor of two numbers and solve real-world problems involving the greatest common factor. So there are two ways to find, well, actually there's more than two ways, but we're going to go over two different ways to finding the greatest common factor. This first page shows how to find the greatest common factor using like listing of the factors, okay? After that, I'm going to show you a different way of finding a greatest common factor that once you get used to it, this becomes a very easy and helpful way to find the greatest common factor. And then later on, when we learn about least common multiple, you can also utilize it to find the least common multiple, okay? So I'm going to show you how to find the GCF using both ways, but for the majority of the homework, you will be using the method that you learned on page 16. Okay, so let's begin. All right, so I have two examples here. So it does say there are 12 boys and 18 girls in Mrs. Kang's class. She's trying to sit students into groups. Each group must have the same number of boys in each group and the same number of girls in each group. So like, you know, 2 boys in each group and 3 girls in each group, something like that, okay? And the question is, what is the greatest number of groups Mrs. Kang can make, okay? So there are multiple ways that I can form groups. For example, I can have one big group of 12 boys and 18 girls. I can also do 2 groups in which each group I'm going to have 6 boys and 9 girls. Okay, so on and so forth. Well, how do I know how many groups I can have? Well, that's the point of finding the common factors. So before finding the greatest common factor, we're first going to list all of the factors of 12. Factors basically means what are the two numbers that when you multiply, it will give you the answer 12. So always your starting point should be, and I'm gonna order these from least to greatest, so watch how I do that. A lot of elementary teachers call it the rainbow method, all right? Okay, so I know that since 1 times 12 is 12, so 1 and 12 are factors of 12. Next, how about 2? Yes, 2 times 6 is 12, so 2 and 6 are also factors of 12. How about 3? Yes, 3 and 4 are factors of 12. I'm finished with factors of 12. Now I'm going to do the same thing with factors of 18. So first, 1 and 18. And then you just keep doing it in order. So 2 times 9 is 18, so 2 and 9. 3 times 6 is 18, so 3 and 6. Now 4 times, no. 5 times, no. 6 times 3, but I already wrote it right here. So then I'm done. These are all the factors of 12 and factors of 18. Now from there, I am going to circle all of my common factors, factors that are common to both 12 and 18. 1, 2, 3, and 6. All of these are common factors of 12 and 18. But among these, the greatest common factor is 6, because that's the literally greatest common factor of 12 and 18. Okay, so the greatest common factor of 12 and 18 is 6. This means the greatest number of groups Mrs. Ken can make is 6. I can make 6 groups, okay? Now, how many girls and boys will be in each group? Well, you know what? Why don't we try making 6 groups and find out? So here's, let me just do it this way. 1, 2, 3, 4, 5. I have 6 groups. So then I have total of 12 boys. So then if I have 6 groups, then hopefully then you can tell that in each group I need to have 2 boys. Now, what about the girls? I have total of 18 girls. So if I divide 18 by 6, I would get 3 girls in each group. Okay, let's see if that made sense to you. So 2 boys in each group and there are 6 groups. That's a total of 12 boys. 3 girls in each group and I have 6 groups, so 3 times 6, I have total of 18 girls. Now also take a look here. 12 boys and 18 girls, that's a total of 30 students altogether, okay? 5 here, 5 here, 5 here, 5 here, 5 here, and 5 here. 5 students times 6 groups is also equal to 30, just so that you understand, all right? So using that same idea, I'm going to do another example, but because we already went over the first example, I'm going to try to go a little bit faster. So florist makes bouquets from 24 roses and 36 tulips. All the bouquets include both roses and tulips. All the bouquets are identical, so same number of types of flowers. What is the greatest number of bouquets the florist can make? So I'm going to use that same strategy, factors of 24 roses and factors of 36 tulips. So 1 and 24, 2 times 12, 3 times 8, so 3 and 8, 4 times 6, 5, no, and then 6 times 4, so I got all the factors. Factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5, no. Now 6 times 6 is 36, but you don't need to write it twice. You just say 6 is a a factor of 36. Now that I found the factors, I'm going to circle the common factors. Always 1, 2, in this case, there's 3, 4, 6, and 12. Okay? Out of these common factors, my greatest common factor is 12. So the greatest common factor of 24 and 36 is 12. Now, what's the meaning of it? This means that the greatest number of bouquets the florist can make is 12. You can make 12 bouquets. That's the biggest amount of bouquets the florist can make, making sure that they have the same number of roses and tulips. Now, it says how many roses and tulips will each bouquet have? I'm going to answer that question right here. So each bouquet will have, okay, so let's think about it. If you make 12 bouquets using 24 roses, Then 24 divided by 12, each bouquet is gonna have 2 roses. And then 36 tulips divided into 12 bouquets. 36 divided by 12 is 3, so 3 tulips. Okay, so far I hope you understood the concept of, finding the factors of a number or factors of 2 numbers, finding their common factors, but out of those common factors, which one is the greatest common factor? Okay, now that we've covered what factors are, common factors are, greatest common factor is, we're gonna go to the next page. And on the next page, what I'm going to do is I am going to give you a strategy on how to find the greatest common factor. But this is the way you're going to show work for all the problems involving finding the greatest common factor, unless told otherwise. And I want to let you know that once you get used to this, our lesson on least common multiple is going to be a piece of cake, okay? All right, so finding the greatest common factor of 2 numbers by using a step diagram. We also call it upside down cake because it's gonna look like an upside down cake, or we also call it the ladder method, okay? I'm going to call it the step diagram, or, well, I will use all of those words, okay? Step diagram, upside down cake, or the ladder method, okay? All right. So first I'm going to read this instruction, which is not going to make sense for now. Once I show you an example, a lot of you will understand right away. Some of you won't, so then I'm going to do some other examples as well. And then I will do a word problem involving that, using that method, okay? All right, so find the greatest common factor of 24 and 36. It's the same problem from the previous one, the one about the roses and tulips. It's the same number, okay? All right, so this is what you need to do. You're gonna think of a factor, a common factor that can be divided into both of these numbers. Then you're going to keep dividing until you can no longer divide anymore. Once you cannot divide anymore, you're gonna stop dividing, and then you're going to circle all of the factors that are on the left side only, and then you're going to rewrite the factors that you circled and multiply them. Once you multiply those, that's the greatest common factor. Now, I understand that it probably didn't make much sense to you yet, okay? So I'm going to now demonstrate what that means. So, to find the greatest common factor of 24 and 36, what I do is I'm going to draw what looks like kind of like an upside down of our division, like a long division symbol, okay? So you draw an upside down, like a little line that looks like a kind of like L, okay? And you write 24 and 36 inside. And then what you're going to do is over here, you're gonna write any common factor that can go into both, but you're just not gonna use 1. And the reason is because if you use 1, if you divide anything by 1, you just get the number itself, nothing's gonna change. So you can divide by 2, 3, 4, 6, even 12, okay? But if I divide by 12, then it's gonna be too easy. I'll get to that in a little bit later. So let's say I'm dividing by, I don't know, 3, okay? It can be any number. That's a common factor to both. So 3, and you divide. 3 goes into 24, 8 times. 3 times 8 is 24. And 3 goes into 36, 12 times. And then you now look at these 2 numbers and ask yourself, can I still divide? Yes, you can. If you can still divide, you draw another ladder, okay? Now, what goes into both 8 and 12? Well, 2, 4, And that's it. So let's say you divide it by 4. 4 goes into 8 twice. 4 goes into 12 3 times. Now ask yourself, can I still divide? No. There's no other common factor but 1. So then this is when you stop. And then what you're going to do is you're going to circle the factors that are on the left side only, and you're going to multiply them. 3 times 4, your greatest common factor is 12. Okay? Okay, but then every year I get students asking questions, but do you have to divide by 3 and then 4? So let me show you what happens if you divide by other common factors in other order. Okay, let's say this time I divide by 2. I get 12 and 18. Stop or continue? Well, I gotta continue, right? I can still divide by 2, 3, or even 6, but let's say I divide by 2. Going in 6 times, going in 9 times. Stop or continue? You gotta continue because I can still divide by 3. Going in twice and going in 3 times. Now I need to stop. Now I want you to notice something. When I stopped, didn't I get the same leftover numbers? Even though I divided using different factors or different orders, I still end up with the same numbers on the bottom. I'm done. So I'm gonna circle these 3 numbers in this case. And let's see what happens when I multiply. 2 times 2 times 3 is 4 times 3, which is 12. I got the same greatest common factor. Okay, well, one last question, Mrs. Kang. What if you divide it by 12? Because what if I already know that 12 goes into 24 and 36? Well, let's see what happens. If you divide by 12, it goes in twice and 3 times. I'm done. So then you circle the 12 on the left side, and since that is the only number that is there, your greatest common factor is 12. So as long as you divide correctly, your answer will be the same no matter which order you choose to, no matter which factor you use to divide, and no matter what order you use, okay? Hopefully you understood that, and now I'm going to show you a couple other examples using the ladder method, okay? So here, I'm gonna find the greatest common factor of 60 and 45, and I'm going to find the greatest common factor of 56 and 80. I'm just gonna show you one. I'm only going to do it once. However, just understand that you can divide using other common factors, and you'll end up with the same answer. 60 and 45. When I think about 60 and 45, I always immediately think, okay, 5. That's what I always think. So I'm going to divide by 5. So 5 times 12 is 60, and 5 times 9 is 45. 12 and 9, I could still divide by 3. 3 times 4 is 12. 3 times 3 is 9. 4 and 3, I don't have any more common factors, so I stop. And then I'm going to circle the left numbers, multiply them, and my greatest common factor is 15. And the reason I also call it upside down cake is because if you take a look, it kind of looks like an upside down cake. That's why, like upside down 3-tier cake, upside down 2-tier cake. Okay, let me do one more and then I'll do the word problem, and that's it for the day. Find the greatest common factor of 56 and 80. Okay, I'm gonna go ahead and divide by 8. Okay, 8 goes into 56 7 times. 8 goes into 80 10 times. Whoa, that's it. I don't have any more common factor. So I stop. My greatest common factor is 8. Look how simple that was. All right. But you could have divided by, let's say, like 2 or 4, and then you would divide one more time, and then you would still get the same answer. Okay. Maybe I'll just quickly show you. Okay. So let's say you divide it by, instead of 8, you divide it by 4. Okay. So then you get 14 and 20. And then notice you still need to divide by 2, which is you get 7 and 10. It's the same number. You need to stop. You multiply the two numbers that you circle on the side. And the greatest common factor is 8. Now, so how do I apply that in a word problem? It's actually even better, I think. Okay, so here I have a word problem. And I chose this problem because I like Panera's bagels. I love their different bagels. Okay, so Panera restaurant has an order of 40 jalapeno bagels and 56 blueberry bagels. Those are my two favorites. So when I typed this up, I, chose those two bagels. Okay, to put into boxes, okay? So each box must have the same number of each type of bagel, same number of jalapeno bagels, and same number of blueberry bagels. It asks you for a few different things, so let's see if we can identify all of their questions, okay? So first, what is the greatest number of boxes that the baker can make using all of the bagels? 2. How many bagels, jalapeno bagels, and how many blueberry bagels will be in each box? Okay, so same question as the roses and tulips, okay? Write your answer in complete sentences and draw a box that shows the number of jalapeno and blueberry bagels in each box. Okay, so I'm going to do the upside down cake. I'm going to put, but notice, since it's a word problem, I'm gonna put 40 J to represent that they're jalapeno bagels, and 56 B to show that those are blueberry bagels. That's just for me, okay? All right, so I'm looking, and I think that, well, I can already tell, but I'm gonna divide by 4, okay? Going in 10 times, and going in 14 times. 4 times 14 is 56. Okay, 10 and 14, is there a common factor? Yes, there is. There is 2. So I'm going to divide by 2, which goes in 5 times and 7 times. Okay, so I need to stop because there's no other common factor anymore. So I'm going to multiply 4 and 2. So my greatest common factor is 8. Okay, but notice, this is a word problem. When you have a word problem, you don't just say 8. You need to write the answer in a complete sentence. Okay, accountable talk, I'm sure you heard that in elementary. It's our district's very big focus. Okay, so I'm going to answer them in complete sentences. Okay, so the greatest number of boxes that the baker can make is, so that's what I'm going to write. The greatest number of boxes that the baker can make is 8. Now I'm going to answer the second question. How many jalapeno bagels and how many blueberry bagels? Now take a look here. You see how you had those leftover numbers? Very big about pens here. Okay, you got 5 and 7, right? as a like leftover number, okay? Well, you know what that means? That means each box is going to have 5 jalapeno bagels and 7 blueberry bagels. That's what it means, okay? So you can say each box will have 5 jalapeno and 7, are you able to see, blueberry bagels. And then I'm going to nicely box that answer. Now, we are done with the lesson, but just in case you're still a little confused about that word problem, I'm gonna go back to the roses and tulips and show you upside down cake and how that works, okay? And then we're truly done. All right, so if you look here, so I'm going to quickly do an upside down cake of 24 roses and 36 tulips. So then I'm just gonna make it simple. I'm gonna divide by 12 because then I know that I'll get 2 and 3. I'm done. So my greatest common factor is 12. Okay, which is the same answer I got here. The greatest number of bouquets a florist can make is 12. Now look, each bouquet will have 2 roses and 3 tulips. They're right here. Okay. All right, so that's it for today. I hope that you guys really watch this as a preview. That way you'll have an easier time in class when we actually do this on Wednesday and Thursday. Or you can go back and review it as well, okay? So I'm going to end the Zoom, all right? Oh, not Zoom, I'm sorry. Bye, you guys.